Or is there something missing?
It should be not this one.
Yeah, it should be not this one, or equal 0.
0.
Yeah, this is how we check if the first bit is 0. If this condition is true, then the bit is 0. Or the switch. If I talk about bit, I'm talking about the switch, yeah? So switch 0 is 0, or it's off. Right? We did this in the previous slide. Now I just want to wait until the switch becomes 1. So if it is 1, it's already 1, that's fine. We'll just go to the next statement. If it is not 1, we need to wait. So I said the condition here needs to be true. The condition that I need to put in while needs to be true when the bit is 0, right? Because I need to wait. If the bit, once the condition becomes false, this means the bit is not 0, the bit is 1, then I will go to the next statement. So it's the same condition. This is the condition that I need to put here. And this is what I'm doing here. I gave you an example with the so here we want to wait for bit 6 to clear. So it's the opposite. In the previous example, we wait for bit to be set, right? Because we want to wait until it's set. So the condition needs to be here. We want to wait for bit to be clear. So this condition should be true, right? Let's use the red. This condition here, when does it need to be true? When bit 6, so this is bit 6, yeah, is 1. I want the condition to be true when bit 6 is 1, because I want to wait until the bit is cleared. So wait until the bit is cleared. Yeah, is this clear?
Yes.
Of course, we need to clear here. We need to choose the bit mask, the right bit mask. We are working with bit 6, and that's it. So x0, x1, x2, x3, x4, 5, 6, 7. So this is bit 6. So we need this one to be 0. Oh, sorry, 1. So we want to keep this bit because we want to check it and don't care about the other bit, right? So we are not clearing the bit 6. We want to keep bit 6 and clear the rest, and then we want to check the result. So this will give me 1, 0, 0, 0, 0, 0, 0, right? So this will be not 0 if the bit is 1. And it will be 0, 1, sorry, if the bit is 1. Sorry, this is x0, yeah, x6. Yes, Hussam.
So basically, as long as bit 6 will be 1, it will always repeat until it's 0?
Yes, correct, yes. So this is what we want to do. We want to wait until bit 6 is cleared. So we don't move to the next statement until, and like the example that I gave you for the first switch. So we want I don't want to execute the statements after this while until the switch is 1, because those are related to this switch. The next statements are related to the switch, to the condition of the switch, is it on or off. So I don't want them to be executed until the switch is on or is 1. So I don't move until it becomes 1. As long as it is 0, I will stay in the while. I will wait. Same here. So we wait for this bit until it's cleared. And this is what I put in the comment here. Yeah, wait for bit 6 to clear. So you need to be careful about the condition. So we do the opposite. The condition will be true if the bit is 0, because we want to stay there, or if the bit is 1. This condition is true, right? When the bit is 1. I want it to be true when the bit is 1. Then if the bit is not 1, the condition is false, which means the bit has changed to 0. Then I can go to the next statement. Like what we did in the if statement, we can write the condition in this way as well, this shortened version. So if this is not 0, then it's true. And this is not 0 when the bit is 1, which means we just wait. Is this clear? So this is related to the testing, but here we need to wait until the bit becomes 1. An exercise, write the C code fragment that clears bit 7. So we need to clear first bit 7, and then on an 8-bit port, and wait for it to be set by an external device. So we want first to clear bit 7. So what do we write?
First, assuming that okay, it's port A, we can end it with use the AND operator with 0x7f. It will clear.
Okay, that's good. So first we can use port A or X or whatever. So if I do X and equal 0x what?
7f.
7f. So we have x0, x1, x2, x3, x4, x5, x6, x7. So the question asks clears the code that clears bit 7 of an 8-bit port. So this is bit 7. So we want this 0, right? We want to clear it. So we will have x0 until x6, and this will be 0. Right? So this is my x. So the last bit is cleared now, is 0. And then we say wait. And then we need to write a while. And then we need to have a condition here, a semicolon, and the condition. So we need to find the condition. We wait until this bit becomes 1. This is what we said. Is set. We wait until the bit is set. Of course, by an external device. If this X is, we are getting it as well, it's linked to an external device. So what do? We need to check this bit, right? So what do I write here? This condition needs to be true when? True when what? The condition that I need to find here needs to be true when what?
When they equal to 0?
When x7 is 0, right? Good. So I need to wait As long as x7 is 0, I need to stay there until it becomes 1. So once it becomes 1, the condition becomes false. Then we go to the next statement. Right? So how do we test it? Like we did in the if statements, right? So if I ask you to write an if statement to check if the bit is 0, how do we do it? So we keep that bit and we clear all the other bits, right? I think is this clear? We did it in the previous slide, yeah? So I need the condition to be true when x7 is 0. So I need to keep this bit, and I need all the other bits to be 0. So I need to get here this bit, x6. X6 is, we cleared it, right? But this x6 will be changing by an external device. We get, this updated, and then we will have 0, 0, 0, 0, 0 here, right? So if this one is, if the bit is 0, we will get this equal to 0. If the bit is 1, we will get this x6 is equal to 1, which means the whole result is not 0. So the condition is, which we did, and I don't know why you are very quiet about this, x and 0x80 is equal to 0. If this is equal to 0, this means the bit is 0. If this is not equal to 0, this means the bit is not 0. And I want the condition when the bit is 0. So this is the condition, x